大家好。募集3030。皆さんこんにちは。山緑大地と申します。Let me use English from here. My name is Yamamidori from Toshiba Japan side, and thank you for your time today, and thank you for giving me such a great opportunity to share our strategies and our solutions for automotive industries. Maybe she mentioned after around 30 minutes my presentation, I will have some questions for you guys, and lucky 5 people can get some gift from Toshiba. So please make your effort to listen my terrible English, please. Okay, so today here I'd like to talk about these topics. First, I'd like to talk about changes in the environment surrounding the automotive industry in relation to case. And next, let me briefly explain the strategy of Toshiba power devices. And after that, let me introduce some specific under-development Toshiba products that can contribute to traction inverter application. Okay, the first one, the automotive industry revolution and electrification. Currently, the automotive industry is experiencing kind of once in a century evolution. Maybe you can understand and you can hear of the 4 major revolutions as the case. C, connected. In addition to in-vehicle connectivity, but also with the advancement of IoT, we can get connection outside of the vehicle too. So for example, we can get traffic congestion information even in the car. And that information makes us to control and to get optimal driving route to avoid that kind of traffic jams. That is thanks to the connected portion. And the next one, A, autonomous. The world of autonomous driving, which was only kind of a dream, that is only happened in the science fiction in just 10 years ago. But now it's becoming in the reality. And the autonomous level is divided into the 6 stages from level 0 to level 5. And already there are some cars can achieve level 4 classes as of today. And level 4 can get, of course drivers can take off, so no hands, without hands, hands off, okay. But not only hands off, but also for playing off. So the drivers don't need any thinking and any judgment for driving while they are in driving. Such kind of level is today. That was autonomous. The next one is shared and services. People's values about vehicles or cars are also changing. With the development of public transportation and enhancement of services, cars are becoming more and more shared. It's like renting bicycle. That kind of service and sharing is already proceeding. That was S. And final one, E, electronic. It may be said that it is our mission of human being to use energy transmission, and power distribution are already available for electric portions. These points are also factors that are promoting the use of electric vehicle. Next, I'd like to take a look at the background of case. First of all, there are global environmental issues such as global warming. In accordance with the Paris Agreement, each country has set medium to long-term agreement targets to achieve carbon neutrality. Next one. Dealing with the increase in traffic accidents caused by elderly drivers is also a major concern and background of the case. In developed countries, the development of medical care and decline in the birth rate that has led to the aging society. And it is necessary to reduce the risk of traffic accidents. Next one. Changes in people's values are one of the reasons why case is attracting attention. In particular, it seems that the number of families choosing not to own their car is increasing, especially among the younger generation who are living in the city center. And another factor is the intensification of competition in the automotive industry. The number of newcomers from outside the automotive industry is increasing. Yeah, who can imagine Xiaomi released battery EV? Only it was smartphone vendors, but they can easily enter such kind of automotive industry. So, yeah, really harsh competitive industry. In such environment, it is believed that the realization to case will be able to respond to the drivers or diverse preferences of individuals. Okay, and now, with these backgrounds in mind, and today, let's take a look at focusing on electronic portion. And electronic portion's major involvement is in addressing global environmental issues and expressing its superiority over competitors. Okay, so here, what is an electrical vehicle? Let's take a quick look at it. Electric vehicles come in a wide variety of configurations, and their configurations are not listed here too. But today, as a representative classification, I'd like to touch a kind of classification. On the left, that is a conventional car, ICE, engine-based car. The engine rotates the wheels and store gasoline to drive engine in the fuel tank. That is the conventional ICE car's composition. And by the way, this is the car, such kind of classification now I'm using. So now I am riding such kind of car in Japan. Yeah. And next one, battery EV. Instead of the engine, a motor rotates the wheels, and the energy to rotate the motor is stored in the battery. In addition, it is equipped with important electrical components called power control unit, PCU, which uses cheapest and affordable battery EV. Maybe when you hear EV, you can easily imagine this type of battery EV. Even there are many EVs. Okay, next one, the hybrid electric vehicle. Even among hybrid EV, the classification is divided into more details, but here you can think of it as the engine and motor rotating the wheels while helping for each other's viewpoint. Gasoline to-drive engine is stored in the fuel tank, and the battery have the energy to rotate motors. The hybrid EV battery is not charged from external, but the battery is charged with regenerative energy during deceleration or braking. On the other hand, next one, plug-in hybrid EV, PHEV, that can support the external charging of the battery. And the motor is often used more actively than the hybrid EVs. Okay, the final one, the fuel cell EV, that is attracting attention as the ultimate eco-friendly vehicle. The motor is used to rotate the wheels in the same way as battery EV, but the energy used is the electrical energy that is generated by chemical reaction with hydrogen and oxygen. It is said to be the ultimate eco-friendly car because only electrical energy and water is created by the chemical reaction. Hydrogen and oxygen, hydrogen is the most abundant element on Earth. And it is necessary to install a hydrogen tank to store a hydrogen cell. And FC stack, which is a module of fuel cells. That was FCEV, fuel cell EV. Okay, that was a quick understanding for representative types of EVs. And in the next page, let's take a look at the battery voltage classification. Okay, the voltage of the battery installed in EVs can be roughly divided into two types, 400 volt and 800 volt. In fact, there are many EVs with smaller battery than 400 volt, but yeah, today I'll just focus on these two types of classifications. 400 voltage system, as of today, are main battery voltage trend as a mainstream. And yeah, we consider as it continues to in 5 or 10 years. The reason why 400 voltage system are mainstream of the battery system, there are mainly two big reasons. The one is charging infrastructure. Maybe you can find many public charging stations that is compatible with 400 voltage system, and some homes compatible with 400 systems are already increasing. And next one is balancing between cost and efficiency. Of course, if we get to 800 voltage system, we can expect much better efficiency, but the price of the car itself will be really expensive compared with 400 voltage system. system, the cost is affordable, and efficiency is also okay. Such kind of level can be achieved by 400. On the other hand, on the right side, there are benefits of 800 voltage systems. The first one is faster charging time. Many EV owners' biggest concern is too much time required to charge batteries. If you want to charge one battery EVs in home, it takes around 8 or 10 hours. And some owners think about that is too long. So if you can shift to 800 voltage system, charging time should be reduced. Theoretically, we can get half of the charging time. And next benefit is extending the cruising range. That is also an important feature for battery, not only battery, xEVs. Within a one-time charging for batteries, how far we can get, that is a kind of characteristic to choose which xEV we want to buy. That is also a good point. And if we can get 800 voltage system, that means the voltage should be doubled compared with 400 volts. That makes current values can be reduced maximum half. And if current level can be reduced, that leads to miniaturize, or we can use thinner cables for battery, for cars, and that leading to reduction of the vehicle weight, that leading to longer cruising range. Such kind of happy procedures have occurred by shifting to 800 voltage system. But there are factors that prevent the shift to 800 voltage system. First one is charging infrastructures. Unfortunately, as of today, it's really difficult to find infrastructures that can compatible 800 voltage system. Some chargers are available, both 400 and 800, but even that, the charging time is not so make big difference. That is today's situation. And that we can expect, for example, China, governments pay money to install many types of 800 voltage chargers. And in China, we can easily find such kind of affordable, compatible chargers. But other countries, not yet, like that situation. Okay, that was kind of the situation. And from here, let me touch to our power device strategies. Okay, Toshiba will continue to develop and manufacture devices with withstand voltage of 750 or 650 that is compatible to 400 voltage system, and 1200 volt devices that is compatible for 800 voltage systems. So developing and manufacturing, and not only silicon-based power devices, but also silicon carbide-based power devices in parallel to support both big battery voltage trends. So our customers can choose the best product for price and performance. We will continue to make aggressive capital investment to further secure we can capture large number of semiconductor chips at once. It's leading to price reduction, cost reduction. And we have already started manufacturing using 300 millimeter wafers. That's equal to 12-inch wafers. We are continuing to make capital investments to secure a 3.5 times supply capacity compared with 2021. Regarding silicon carbide-based power device development, we already have a record of mass production and sales of silicon carbide MOSFET in a product group for railway applications. Based on the technology cultivated in these railway applications, now we are developing a SiC MOSFET product line for other applications. And the orange portion, especially for automotive markets, that kind of our key targeting applications. Okay, so that is the final topic from my side. Toshiba products for traction inverter in automotive. The traction inverter is housed in power control unit inside of the xEV, converting the DC power of the battery into AC power to rotate the motor is an important job of the traction inverter. Yeah, we can say that the traction inverter is the heart of the xEV that controls the motor. And traction inverter's block diagram is like that. Main portion, right hand. Yeah. Automotive motor needs three-phase half-wave circuit to rotate appropriately. So totally 1, 2, 3, 4, 5, 6 switches required to make inverter circuit. And as orange portion, that is the power devices. And depending on performance, price, car vendors or inverter vendors can choose using silicon-based IGBT or silicon carbide-based MOSFET. That is today's situation. And as I said, with power devices, blue portion, isolated gauge driver are also used, also required to make inverter circuit. Because control unit that can be operated less than 15 volts. On the other hand, in power stage, switch portion, they need to handle like 400 or 800 volts. And the gap between high voltage and low voltage is connected by gauge drivers. So here, isolation is required. So, in the traction inverter, power devices and isolated gauge drivers are the main components. From here, let me briefly touch our under development products. It's not, we do not have plenty time to explain all of Toshiba products today. And so yeah, I picked up some of them. And if you have further confirmation, if you need further information, we have booths out there. So yeah, please come there after this presentation. Yeah, the first one, our reverse conducting IGBT die that is compatible with 800 voltage system. Normally, when using IGBTs in traction inverters, it is necessary to use free-wheel diode chip in combination with the IGBT chip. Yeah, this means you need to use 2 chips per 1 switch. Here, reverse conducting IGBT is a product that consists of an IGBT and diode on a single chip. The chip is under development, is capable of carrying a current of 400 amps with 1200 voltage. Current sensor part, temperature sensor part are also provided, that's leading to easily monitor the real-time status of the chip. That is one of our under development products. Next one. Yeah. Combining using previous page's chip, we are under developing such kind of modules that is 2-in-1 approach. That if you can make 3 pieces of that, you easily can make the inverter circuit, 3-phase 2-in-1, half-bridge inverter circuit. And we are already considering to support designing a cooling system to using our dual-side cooling packages. And after that, SiC MOSFET for traction inverters. SiC MOSFET traction inverter mainly targeting on less than 2 million class for each phase. And to achieve such kind of low on resistance, parallelizing some SiC chip is a kind of industry standard. But SiC has concern regarding reliability. They have the so-called BPD based on dislocation, kind of the seed of defect. And to avoid such kind of difficult dislocation or defects, we decided to make SiC MOSFET parallelly using Schottky barrier diode on a single chip. Using such kind of constructors, our SiC device can support really high reliability, no characteristic fluctuation even in longer time usage. Yeah, and now we are making such kind of improved characteristic versions too. So if you need further information, please contact us. Thank you. Okay, and using such technology, we are under developing 3 bare dies for SiC MOSFETs. And using this kind of bare dies, we are considering to develop 2 types of modules. One is 2-in-1 half-bridge. The other one is 6-in-1 half-bridge. Okay, and gate drivers with slew-rate controlled functions. I really wanted to explain, but sorry, it's already